Welcome. I'm going to introduce a very important topic called linked list. Linked lists are an alternative to using arrays. With arrays, you have a finite limit to how many values you can store in a collection. A linked list is based upon dynamic memory allocation, so you really have an unbounded amount of unbounded capacity. The best metaphor for a linked list is a train. What does a train consist of? Well, it really has an engine at the front, followed by 0 or more boxcars that can contain cargo. And finally, a well-structured train has a caboose on the end. And the caboose really says no more boxcars. It marks the end of the collection of boxcars. So when you use a linked list, we rely upon a data structure called a node. And the node has two parts. One is the value field, or you can think of this as the cargo field. And the next component of the structure is a link. View this as the link that connects one boxcar to the one that comes after it. So let's take a look at the declaration. We see that the data in this case is a single integer. It can be any data type, so just bear that in mind. And the next field is really a pointer to another thing that looks like this. So the next field points to another node. Now let's talk about the engine. The beginning of the train, we typically designate a pointer, and the pointer can have various names, but we'll probably use most of the time the name head, which really means it's the beginning of the list. Think of this. The only way to access the train is through the head. Notice that the head is not one of these guys. It's a single pointer, but it has the ability to point to one of these guys. All right? So let's take a look at some code here. With this line, we basically allocate a new node. We have a pointer called P, and we allocate a new node. What happens when we allocate a new node? We really point to this new node. The value of P becomes a pointer that accesses the new node. Notice that in the beginning, the new node has no values filled in. All right? Once I have allocated a new node, I can start my list using that node, newly allocated node. This statement will make head point to this node. It is important to remember that head is pointing to the whole node. It is not pointing to a field in the node. All right? We saw last time that if I want to access a field in the node, I'd have to use the dash point operator to access a field. All right? Now let's go ahead and complete these steps. If I want, what is this step attempting to do? It's an assignment. I want to put 14 where? In the value field of the node that head points to. So I want to put, I'm going to do it down here. I want to put 14 here. And I want to say the next field is null. We draw it this way. And what does it mean? This basically says end of list. So let's use some terminology now. A list is often referred to by the pointer that accesses the first node. So technically, this list that we see here, we can say this is list head. Right? And the only way to get to this node is through the entry pointer. Reiterate, head, look at it. It has only one value. It doesn't have two. So head is not a node, but it points to a node. Now here's a question. What if I say head point val? We know what we intend is to access the val field of the node that head is pointing to. In this case, what node is head pointing to? What does null mean? Well, null means I am not pointing to anything. So if you try this, guess what's going to happen in your program? You're going to die. It's a sudden death, okay? Now what about over here? Head is a pointer, but the question marks mean that it's uninitialized. So what's going to happen when you try this? Are you going to say the same thing? What's the moral of the story? It is very critical when you build a list to always make sure that you can check to see if you're pointing to anything. And the way that we do that is that we typically, when we first declare our head, we will say node star head. I'm going to just say H. I'm drawing too slow. We will, when we create the head node, we will always initialize it to null. Null is uppercase. And that way we always start with a list that we can check to see if it's null. So that before I do things, I can often just put in the check if head is null or not equal to null, then I will know what to do. Because if it's null, I will be sure to never say head point anything, because it will crash. All right, that's the first video. Next, we're going to jump ahead and assume that we have a list, and then we will show you what the pattern is for processing that list.